Welcome to ZKast, everyone. I'm Z.S. Caravallo from ZK Research. And today I'm joined by two distinguished people from Arista Networks, who I consider, maybe the top high-performance networking vendor today. I have with me Fred Hsu, who's the Distinguished Solutions Engineer. Doug, want to say hi and do a quick intro on yourself?
Hi, Zayas. Thanks. Yeah, I've been at Arista for almost 10 years now, covering all kinds of things, but I think today we're going to dive into DevOps and CI and stuff like that.
Yeah, well, you gave it away now. Spoiler alert.
Sorry.
So that's okay. And I think everybody's been at Arista for at least 10 years. And also joining us is Doug Gourlay, who, if you're in the network industry, you really don't need any introduction, Doug, but why don't you, do a quick one for the people who might not know you.
Sure. Douglas Gourlay, VP GM for software here at Arista, look after a lot of I think the fun projects that the company gets to build. And, I've been joined Arista in 2009 and again, get to do all the cool stuff usually with Fred.
Yeah. And as Fred mentioned, we are going to be talking about DevOps and software and things like that often we don't necessarily associate with networking. Networking, I think, is, in fact, when you think about the impact the cloud and software's had on infrastructure, it's changed almost every part of infrastructure. But it's fair to say that, some of your larger incumbent competitors are still living in the older world of, monolithic software. And I think that's largely become the norm. And so this industry hasn't embraced cloud and DevOps as fast as other ones. But I do think change is needed. And part of that is because the role of the network has changed, right? Businesses are moving much faster today. They're all becoming digital. Whenever I talk to even business leaders, there's a realization now that the network is more important, but digital businesses, their hallmark is they move with speed. And so consequently, the network has to move with speed. And Doug, I want to start with you. You obviously talk to a lot of customers, right? Your ecosystem of contacts is pretty big. What's going on with the network just at a high level, and why is the role of it changing?
There's a couple of things there. The first is, in one regard, the role of the network isn't changing. It still connects everything, okay? But if you think of, as an example, WAN architectures, it used to be that, it's always been the WAN architectures kind of mirrored application architectures. And what I mean by that was, we used to build WANs with point-to-point links connecting branch locations back to data centers that housed mainframes because we had terminals with 80 by 24 CLIs that connected back to this mainframe. And so point-to-point connectivity rooted off of...
It's hard to call that a network, but okay.
It was a network, right? Well, then we watched this evolution of frame relay and MPLS, which was begot by the need to have voice communication and branch-to-branch communication and site-to-site comms happening, 3-tier web architectures and so on, and we ended up with that architecture. Well, if you look at it today, what do we see? We see the most distributed application development environment, where when I start my day, I'm logging in and getting a single sign-on against Okta. I'm connecting to an application that runs part of it in Amazon, part in Azure, and 4 other SaaS companies that are operating with it for it to get its job done. And some of the data goes back to the data center and the central applications that IT supports. You combine all that and go, what is the network architecture that is designed to support the application environment of these distributed multi-vendor, multi-service applications that run geographically distributed around the world? It's the most network-intensive application architecture we've ever seen before. Now, whether you're building networks for data centers or campuses or in the WAN or across the internet, I don't think that changes. The relevance of the network to business is more critical than ever before. The last thing I'll say with that is I was on this panel discussion last week, and the question was, what is the biggest thing coming that's going to change the way we have to design, build, architect networks for the future? And our thesis, kind of the collective thesis of the panelists, was that it's AI. Not like, AI, kumbaya, right? But AI, a set of machine learning and AI applications that run on the business's data, meaning I need to build it as close to my data as possible, whether I'm doing some sort of large language model, for, GPT for customer support, or I'm doing image recognition for healthcare to identify, do cancer screening, whatever it is. I need the processing of this in near real time, as close as possible to my data, And this is the set of technologies that we believe might be like the next cell phone, right? The next smartphone, the next major technology shift that creates new business value in the enterprise and carrier and cloud world. And that's going to require networks that were designed for very different traffic flow patterns than we've ever seen before.
Yeah. So Fred, I want to pivot over to you here. Doug finished off talking about network architecture. Now, when you look at the network architecture that's used today, it's largely the same. It's been the same for decades. In fact, before I was an analyst, I was in corporate IT, and I think most networks are largely the same as when I was an engineer, right? So, clearly when you look at the rest of IT, lots of things have evolved, but what kind of problems is legacy architecture creating today?
I think, well, if we think about really legacy architectures, we really design networks to be very much snowflakes, right? We design things to be, I'm going to make this particular part of the network address this part of my data needs, and this other part to address a different part. And what I've seen the trend kind of leaning towards is making things a lot more cookie cutter, right? How can we establish a well-designed design pattern that we can replicate across multiple pods? We can replicate in the campus and the data center, use the same architecture, right? So I think it's the rise of the leaf spine design, the rise of, thinking of things as design patterns that can be replicated easily. And then that leads itself towards automation, towards easier troubleshooting, towards easier, simpler networks too. So I think, we used to slather all kinds of different protocols, IPX, AppleTalk, all these different things all over the network. We really, nailed that down to Ethernet and IP, I think, at this point, for the most part. So as we actually standardize on things, I think we can simplify things and make the network more reliable and more robust.
Yeah, I'm just going to echo that, Fred. There's been a tremendous homogenization of the design patterns. And if we looked at 80% of the enterprise customers that I worked with in my previous job in the early 2000s, I would have seen massive disparity in architecture. When I look today, 80% of our enterprise customers are addressing, for instance, their data center design with an incredibly common repeatable design pattern. A repeatable design pattern enables automation to execute at scale, making it worthwhile to implement that automation. And that's why, when you ask, what's the thing coming or that's happening today that's incredibly disruptive and forward-looking to the network, the business driver is planning for future business applications. The operational driver is taking software best practices and principles and applying them to the day-to-day operations and execution of the network. How do we treat network configurations as software and repeat it times thousands and thousands of leafs or pods or racks or whatever unit of consumption you want? But consistency in that design pattern enables the value to be created.
Yeah, and I think this concept of the network as software has been the calling card for Arista since the company was founded, right? But I think you've gone through, I don't want to say baby steps, but gradual steps along the way, to evolve the network in a way I suppose that was comfortable with network architects. You're not throwing something completely different down, right? And so, when you think about the journey that Arista has been on, and if you think about the way like a traditional DevOps cloud engineer would work, how closely mirrored is your software versus what somebody might actually, like a true cloud, like an AWS engineer, use?
Yeah, I'll start with, I think one thing that Doug and I both really see as an inflection point when it comes to network and software, treating it as software, is the API service, right? So making the network programmable, having an API service, having a way of being able to treat the network like software. Prior to that, everything was built on the CLI, right? We were all writing scripts that SSH'd or telnetted into the box and ran CLI commands and got the output and scraped it and did a bunch of regexes and all kinds of crazy stuff to deal with.
I remember that.
I'm having a flashback.
Stop, Fred.
Stop.
I know, we're gonna go down a dark hole.
Desk right now in the middle of the call.
Right. So, but I think, and as you mentioned, this has been part of the story that Arista's promoted from the beginning, is having a programmable network, having an extensible operating system, having those API services to work with, really enables all of those kind of things that you just sort of mentioned. How do I equate myself to what a cloud engineer would use? Well, all the cloud things are built upon APIs, right? At its core, if you're using Terraform, if you're using AWS services, all these things build on top of an API as the base level. Then what we have to do as, as Arista and as a community is then build the tools on top of that leverage those APIs and create value for our end users.
And
All right,
I think,
now,
let me just throw
go
one
ahead.
thought. Fred, you mentioned Terraform. And part of it is, do we build our infrastructure in a way that is similar to what, do we recommend large scale enterprises build infrastructure that has a very common look and feel to the design patterns we see in high scale, highly automated, extremely agile cloud environments? Absolutely. But the other is, how do we treat the operations of that? And running Terraform as a declarative provisioning tool to instantiate a VPC in the public cloud and spin up certain workloads is cool. It's actually really awesome to do, and use it to normalize that programming and configuration and provisioning across multiple cloud providers. Being able to use the exact same programming model, the exact same tooling, and trigger a pull request into my network CI pipeline that creates a VPC, creates a VRF, creates a EVPN, adds the IP addressing from an external system of record, makes the configuration changes, tests it, approves, sets the configuration changes to be approved in an ITSM system. After approval, the deployment happens, it retests it, auto documents it, creating that type of enterprise workflow that is extremely parallel to what an application developer does in their world, but treats that entire network configuration as version controlled, merge conflict resolved, auto documenting software. It is incredibly transformative.
Yeah, well, it's more than cool. It's fast and it's accurate, right? Which is not traditionally what CLI-driven networking has been. Now, I know you recently introduced your CI pipeline, and the concept of CI/CD, very common in the world of DevOps, not very common in the world of networking. And so, can you first describe what a CI pipeline is, and then how does that relate to networking and the Arista data lake that you just announced as well? So.
Sure. I'll kick it off and I'll quickly pass to Fred, who actually knows what he's talking about. The CI pipeline is a workflow. Okay, it's the automation of your automation. When we think about network automation, we used to think of it in the context of, I wrote a Perl script that debugged AppleTalk zip storms at a university, which I did once. Then it became, I'm doing Python scripts and programs that execute more effectively. Cool, because it was easier to write. Now it's, how do I take the entire system and say, I want to start with, how does change come in? Well, change can come in by somebody adding a new NTP server in my IP address management system. Change could come in by an update to a template that's version controlled and stored in a source code management system. Change could come in by one of the variables that are composited into my configuration, being a DNS server or so on, being automatically updated. A Terraform script declaratively creating new segments. These are all forms of change coming in. That change creates what's called a pull request. Now, this is in a workflow management system like GitLab or our own tooling, but the concept is it's a change. And this change should be able to flow through a series of steps called a pipeline, steps that do things that are of value. Things like test and model the configuration to make sure it's going to work before you try to push it. Is it going to block critical services? Is it going to black hole traffic that's necessary for your network? Gosh, I used to be, segue for 1 second. I used to be massively enamored of a feature called configuration commit confirm. It means I messed up my network. Somebody called me and told me something broke, and I roll back my change and it works again. Trust me, in the late 90s, that was magic, man. That was like freaking amazing. And then you have to ask yourself a different question today. Why did the network let me deploy a configuration command that rolled like no router BGP across the entire data center network and crashed it? Why was the network stupid enough to allow that to happen? Or take it a slightly more evolved and less drastic step. Shouldn't we have tested the configuration before it went out? And then pushed it out, and then automatically tested it again. And in case it broke something, let me know before I get a call from my client.
Now, Fred, can you get into some of the technical aspects of this? And I described what Arista has done as almost has gone on this journey, right, of moving the operating system purely to software, and then you had with your NetDB, then you rolled the network data lake, and then you built this on top of it. So technically, can you describe what you're doing here with your CI pipeline, how it relates to the other building blocks that Arista's put in place?
Sure. Yeah. I mean, I think, back to the earlier point, this really starts at the API and then builds on top of that. Because without the API there, it's really hard to do any of this more fancy high-level automation. And I think one of the terms that Doug and I like to use when we talk about CI, it's automating your automation, right? So if you kind of think about the journey, we went from CLI stuff to, let's say, Python scripts that interacted with the API, then to something like an Ansible playbook, right? So, okay, now I've got automation. This is great. I can configure 100 switches with one Ansible playbook, and away we go, or a Terraform template, whatever it is. But that's still me as an operator manually triggering that Ansible playbook, right? I'm like, okay, well, I'm going to push out this change during my change window right now, and here we go. With that is all the testing, all the other things that we've talked about. But if, as an operator, I have to do all that stuff manually, it's much less likely that I'm going to do it. And it's much less likely that I'm going to have thorough coverage when it comes to that testing. So how do we actually automate the entire process? So now it's not me manually executing tests before, me creating the playbook and running it, me then also running tests afterwards and making sense of it all. So this is where the CI piece comes in. So the whole point is to automate that entire workflow where I check in my change into a repository to Git, to most likely Git or something like CloudVision, and that then triggers the next step of the pipeline, right? So it's okay, well, we saw a new piece of code come in, or in this case, a new config come in. All right, now let's go ahead and run the tests. Okay, did it pass? If it didn't pass, fire an alarm, bring that back, and let's take a look at it. And then just, again, have the automated system, the CI pipeline, step you step by step through this workflow process until you get to the end result, which is new configs deployed, sources of truth updated, documentation generated, and we're ready to go for the next round.
Yeah, and so from a workflow perspective, since you mentioned that, what is, from a network operations standpoint, describe the workflow kind of pre and post CI pipeline, like how, a day in the life of the engineer. What would my job look like after that?
Right. So really, it's now I'm, instead of working with CLI, instead of working with or even Ansible directly, I'm just working with my code repository, right? So I'm just either editing a editing a YAML file in my text editor and committing that, and then that triggers the whole workflow. Along with that, also comes the responsibility of doing, as Doug mentioned, PRs and code reviews. So as part of this workflow process, we're going to have checks and balances in place so that you could say, okay, as an engineer, let's say I'm a junior engineer and I'm adding this new configuration to the BGP parameters. Okay, well, that goes into the system, it runs through its tests, but then it also sits there and waits for someone else to come back in and give a +1 and say, hey, yeah, okay, this looks good. We can move along with the workflow. So it's also not just automating the workflow, but also incorporating the change control process. So my workflow, to answer your question more directly, is a lot more like what a software developer's workflow is. I'm making changes, I'm committing that to a repository, I'm pushing that up into the general CI workflow, and then letting that go through its process, versus me on a box, SSHing in, hammering out all the configs, or copying, pasting from Notepad into my config or into my CLI, and then running a bunch of pings to see if everything's still up.
And in this modern environment, we have customers today, or some of our largest enterprises, who have some very simple moratoriums. No one is authorized to touch the CLI anymore without having a managing director level sign off at a major financial institution or SVP level at an enterprise. And it's
I think for the engineer too, there's a bunch of things. My advice to IT pros and engineers is, if you're doing things today that aren't really resume building, you shouldn't be doing them, right? You should find a way to automate them out of your job. And what you're talking about is a lot of those mundane tasks of, looking at, a lot of those configurations. No one's ever going to hire those people in the future for those types of skills, right? They want software skills and things like that. So it's good for them too. Now, I know in conjunction with the CI pipeline, you announced something called Arista validated designs. And when I think historically of validated designs that have come, that I grew up with, anyways, 20 years ago, those were just configuration guides. And from what I understand, these are much deeper than that. So can you go through what an Arista validated design is?
Yeah.
Sure.
Actually, it bleeds right into what I wanted to talk about with the testing piece as well. So an AVD is essentially taking those design guides that you're used to, that we publish and everybody else publishes for network best practices, and codifying that into a repeatable design pattern and today it's mostly Ansible templates, but it could also be other mechanisms if you want as well. So it's taking those design patterns and turning it into code. So now, instead of me having to copy and paste all of the stuff that's in the Arista design guide, putting it into a text editor, modifying it to match my IP address subnets and everything like that, I get a template handed to me that I can just fill in with the variables, and it will generate all of the configs and all of the things that I need based on the Arista best practice network designs. Now, a couple of things that I like to point out with AVD in particular. One is that it's completely open source. So you can go to arista.com's GitHub page, go to AVD, and you can get access to everything. All the data models, all the templates, everything is out there in the open source, which I think is really cool. Another piece here is that we've taken a very sort of abstracted model approach to this. So we're not just saying, here's a bunch of Ansible templates to manipulate your CloudVision or EOS configs. What we've done is say, give us network level parameters, right? Give me the range of BGPAS numbers or the IP subnet that you want to assign to your network. And what we will do is then procedurally render those out into what's going to get dropped onto the boxes. So I'm no longer thinking about things at a switch by switch level. I'm thinking of things at the network wide level. Now, as a nice sort of fallout from that is, not only are we going to generate configs for you, but we can also generate other artifacts as well. So I can automatically generate documentation. And I think all of us on this call will agree that network engineers historically hate doing documentation or are very bad at it.
What's documentation?
Exactly.
I think you don't do.
We also, based on the input parameters, will automatically generate these tests. So we keep talking about testing. How can I do testing before and after? Well, somebody's got to write those tests, and that can be a real pain. And so with AVD, we automatically generate hundreds, if not thousands, of tests for you based on the network design that you proposed, that we can then execute when we go through the pipeline. So it's really having that abstractive layer model really is beneficial in many fronts, where we can do lots of cool things instead of working at the CLI switch by switch level.
Zeus, we had a customer deploy a 60,000 port campus network in 2 weekends with no human touching a CLI for any portion of the deployment. The test cases Fred talks about looked at the cable plant map that was documented in a cable system of record and correlated that with the LLDP neighbor information from our switches, the PRBS test that could be run on loopback within a switch, and so on, and automatically generated the test, found a single digit but 3 to 4% cable error rate, and then automatically generated the work orders for the local union contractors to go and fix the cables that were not properly cabled.
And so how many AVDs are there that you announced?
So currently we have two primary ones that are, like, I guess I'd call them GA. One's for a layer 3 EVPN design, and the other one's for a layer 2 leaf spine. But we have 2 or 3 other ones sort of cooking right now.
I like to think of it as there's one AVD, there's multiple deployment models within the AVD. Yes.
Got it. Okay. And I think we're running up against the clock here. I know, Fred, you wanted to do a demo for us as well, right?
Yeah, I'd love to take you through a quick little demo of how all this stuff looks when you're actually working with it. All right, so what I'll do is I'll take you through a quick demo of sort of an entire workflow using CI/CD and CloudVision and a bunch of other cool tools, AVD, all the things we've talked about. So the way this workflow starts is we have end users who want to make requests against the network. And so we've enabled them to have sort of a self-service portal, in this case using Slack, so using a chatbot to interact with the network. So the first command here I'm doing is, let's say the user just wants to see, hey, what VLANs are currently available on the network. So they do get VLAN and they get a list. And then they say, okay, well, I want to see what VLANs are currently assigned to my hypervisor, right? So they can query for their hypervisor. It says it's in a particular port group. And here are the VLANs that are currently assigned. Now, all of those requests behind the scenes are going to a source of truth. In this case, we're using Nautilbot, but it could be, I mean, take your pick, what you want to have be the source of truth. But all these queries are just going back to Nautilbot saying, hey, give me the list of VLANs assigned to the hypervisor and spit those back to the user. Okay, so now what I want to do is I want to add a new VLAN. So as a user, again, I'm going to say, I want to add VLAN 200 to my hypervisor. So hypervisor 1. And now you can see when that triggered, we've got the request that was received. And because we decided that adding VLANs is not a real big deal, we're going to auto approve this. So we're going to just let this fly right through the workflow. But we do generate a ticket ID based on that. So now what's going to happen is we're going to push this whole workflow through a CI process, and we're actually going to push this through Cloud Vision as part of the CI workflow. So what's happening right now is we're taking that request to add a VLAN, and we're running it through AVD. So we're passing this new variable into the AVD templates and into the AVD model, and it's generating the configs. It's then taking those configs and committing them in. And then in this case, like I said, it's auto approved. So we're going to kind of just skip right through the approval process. And then we're going to go on to starting to execute our validation tests, right? So once the kind of initial rendering and everything is done, we can move into the validation test phase. And this just takes a minute or two as the system kind of rolls through the process. Now, what I'll mention as we're kind of waiting for this to run through is when I make a change, no matter how small it is, so in this case, just adding one VLAN, we're not just going to test that one little change, right? So I'm not just going to test, does this VLAN show up on this particular switch? I'm going to run through every single test every single time, because you never know what the ripple effects of one change could be, right? I change an ACL here, maybe my local switch still looks good, but I broke somebody, further down the line. So we're going to execute every test every time. And again, back to the whole automating your automation, this is where having this workflow automated is really powerful. As a network engineer, you don't want to sit here and have to execute all of these things manually every time. I just want to make a change and have this stuff automatically work itself out. So you can see we pushed the, oh, sorry.
I was going to say, Zayas, that hits a lot to what you described earlier, the scenario where combinatorial problems, complex failures, and stacking by not doing regression testing, but viewing that every change gets a full suite of testing, again, buys down that risk, right? And helps us understand if we did make a change that was disruptive and where it was, or if we're less likely to be affected by something and be in the free and clear moving forward.
So what we're going to see now is that the Slack bot is responding back to the user saying, hey, your ticket's done. We've rolled out those changes. So the user gets positive confirmation that it executed. I'm going to come over here to a dashboard. So we built some specific dashboards for this workflows where I can pull up that ticket ID, and now I can see all of the tests that were run. So here you can see for that one little change, we ran 202 different tests and they all passed. And you can see the changes are all over the map from NTP to BGP to all kinds of stuff. So again, we tested the whole network because we made this change. And if I come back here to my source of truth, we've also made sure we cycled back in and updated everything documentation-wise, source of truth-wise. So now when the user does a query to say, give me the VLANs that are on my hypervisor now, that's going to be up to date and everybody's in sync. So now VLAN 200 shows up and also shows up in my source of truth. So now we'll take a slightly different approach and we're going to say, let's delete a VLAN from that hypervisor. So I'm going to say, I want to remove VLAN 300. And the difference this time is that because it's a bit more of a disruptive change, if I remove this VLAN, I could mess somebody else up. You can see that's been submitted for approval in this case. And so for the approval process here, we've actually thrown that into Slack as well, where all my administrators can be on this particular Slack channel, and they all get this notification saying, hey, somebody's requesting a change. Here's the ticket ID. And here's the link to go to and go and take a look at this change control process. So it's the same workflow, but we've added that level of change control into the mix. And so right now it's sitting here, it's rendering out AVD. And now as the user, or sorry, as the administrator, I can go back, I can look at the changes, I can look at the diff, and I can say, okay, looks like they're just adding or removing VLAN 300, and that's okay with me. So now the administrator can approve this. And now it'll sort of go through the exact same thing that we did earlier. We just inserted that extra level of control there. So now it's going to go through, deploy the changes out to the switches. So again, it's going to take those configs and push them out. The user will get notified that, hey, it did get approved. It's not rolled out yet, but at least you know your ticket got approved. And now after we're done pushing out the change, we'll run through the validation. So again, we're going to run through all of that litany of tests. And this just takes a minute or two as it starts to run through that 202 different test cases again for the network change. But the end result here is the user got very quick, easy responses to the changes that they wanted to do, as well as being able to query the network. The network administrator's burden is a lot less. They didn't have to deal with something easy like adding a VLAN that just got completely automated here. But everything's been fully tested and fully documented. So I have the confidence of knowing that, these changes that are being automatically executed by the system are good. The tests pass, nothing broke, and I've got documentation to back it up. And so here you can see everything finished off. The ticket ID pulls up for the workspace or for the dashboard, and we can see all the tests passed again. So everything looks good.
All right, Fred. Well, thanks for that demo. And Doug, Fred, thanks for joining me. That was a fantastic introduction to, like I said, what is a very commonly used software principle now coming to the network. And, it's a good lesson, I think, for the IT pros and network engineers watching this too, that skill set refresh is always important, but it's particularly important today when so much of the world is moving to cloud and into software. So anyway, so Fred, Doug, thanks for your time. I'm Zeus Caravello from ZK Research. Don't forget to hit that subscribe button, and I'll see you next time on another ZKast.